Good morning, students. We're going to be starting lesson 5 today. And I just want to remind you that all the work you did last week, lesson 1, 2, 3, and 4, they were due on Friday, December 4th. I have posted those assignments as an average grade in your PowerSchool, so you can see that grade in PowerSchool as well as Google Classroom. I will, however, take late assignments all the way up until this Friday, December 11th. That is when your final grade will be due. Okay, so just know that I'm giving you this week to get all of your assignments made up and all those assignments turned in for full credit. So make your schedule, stay on task, be productive. You can do this. Okay. So today for lesson 5, we're kind of combining all the review that we did last week. We started the week looking at stars. We moved into the scope and the scale of our universe. We started looking more at the end of the week at our solar system, where we were looking at planets and moons and what are all the parts that make up the whole of our solar system. Today we're really going to look into how do all of those objects, those celestial objects, all of those parts, how do they stay in orbit? How do they continually revolve around the sun? And how do they spin or rotate on their axis? Which force is acting in our system of the solar system? So today we're going to be looking at a gravity in orbits lesson. You're going to need 2 tabs open to complete this assignment successfully. So the first thing that you're going to need to have open when you click on your classwork, you'll notice under independent practice, there is a PDF assignment I want you to open using Kami, and you're going to need this link. It's the gravity in orbits. This is a simulation we're going to use. So as you're completing today's lessons, please make sure you have this assignment open, and please make sure you've clicked on the link because we're going to be working on a simulation to figure out how these objects in space move. Okay, so the first thing you're going to notice on number 1, all I want you to do using the drawing feature is just draw. How do you think Earth moves in relation to the sun? You can draw arrows and you can kind of show me how you think Earth moves. In addition to just showing me the rotation and the revolution of Earth and how it works with the sun, I also want you to draw those arrows, and I want you to think about what force do you think is acting on both the sun as well as the earth? What force is keeping the earth in rotation, and what force is keeping the earth in revolution around the sun? Once you complete number 1 and number 2, we're going to move down to number 3. So what you can do to be successful in this assignment is as we go through the direct instruction, you can pause. You can pause this video right now and you can complete problems 1 and 2. Or you can watch this video all the way through and then open up your independent practice to be successful for today. Okay, so again, just a reminder, number 1, how do you think Earth moves in relation to the sun? You're also going to include arrows that show the force that you think might be acting on both this earth and the sun. Then looking at number 3, how do you think the earth is going to move if that force didn't exist? So right now, my advice, pause the video. You're going to be drawing numbers 1 and 2 on this picture right here. And then you're going to be drawing number 3 on this picture right here. So go ahead and pause and complete number 1 through 3. Okay, welcome back. So what we're going to focus on, or what you've already done, is that you are drawing the motion of planets. We're going to look at moons and satellites in the simulation in a second. But you're also talking about this force. What is this invisible force that's controlling the motion in our solar system? You're also going to identify variables. What are things that are changing that might affect the strength of the gravity? Is the force of gravity getting stronger, or does the force of gravity get weaker as we change certain variables on our simulation today? And then the last thing you're going to do on this assignment is you're just going to predict. You're going to be predicting how motion would change if gravity was stronger or if gravity was weaker. Okay, so thank you for completing 1 through 3 on the top. You just did some drawing to kind of show me the motion of the planets and the moon. Now, we're on part 1. We're going to start to understand motion. You're going to open that gravity and orbits simulation. Remember, it is linked in your independent practice. And all I want you to do first is just kind of explore, play around with all those controls. Play around with the variables that might change how the Earth, the moon, and a space station, how they might move. Okay, let me show you what that looks like. When you click on the link, you're going to notice you have a sun and a moon. They're the same images that you saw in problems 1 through 3. Notice up here, I can change which objects that I'm manipulating. Which objects am I changing the variables? So right now, we just have the sun and the earth. If you click right here, notice we've added our moon. If you want to focus specifically on this system of just the earth and the moon, look, you can click here and you'll notice the earth and the moon and how those objects connect and how a certain force makes those objects move. Or the last variable that you can look at and change is how does the earth deal, or how does the earth depend on these certain satellites that are floating around in space. Okay, so you're just going to click on these, you're going to play around, and you're going to see how they move. One thing you'll also notice as you start playing around with this website, you can turn gravity on or you can turn gravity off. You'll notice in question number 3, it asks you, what do you think will happen when we turn off the gravity, or what would happen to the Earth if there was no gravity? So notice you can toggle off for no gravity, you can toggle on for let's see what gravity looks like. Okay, one thing I want to make sure that you have clicked and turned on for the entire simulation is we want to look at this force. Okay, yes, it is the gravitational force. It's not necessarily invisible now. Okay, please make sure this is toggled on. And this is where you will see the strength of the gravity. Okay, don't worry about velocity for this particular assignment. I also want you to make sure that your path, toggle that. That's going to show you the motion in the direction that those objects are moving, okay, in space. Another thing I want you to toggle is the grid. When you have this grid on, it makes it easier to see the path, and it also shows you the relative distance between objects, and that will help you kind of manage where you put objects if you want to change certain variables. So please make sure as you're playing that your gravity is turned on, your path is turned on, as well as the grid. Okay? Down here in this section, you'll notice mass. Mass is just the amount of matter that's in that object. Okay? So when we talk about matter, matter is made of atoms, and those atoms can rearrange to create different substances. And as those substances create in space context, we're looking at the mass of our sun, as well as the mass of Earth and its moon. And if we change these, meaning we move them, you're going to notice certain things changing. These are our variables. If we change the mass of the sun, maybe gravity also changes. So kind of play around and see what happens as you change the mass of our sun as well as the mass of our Earth. How might that affect the path, the speed, the distance, or the time that it takes for certain objects to revolve or move around other objects? I'm going to leave everything the same, okay, with our grid toggled on, our path on, gravity force on, and I just want to look at this system right here with the sun, the earth, and the moon. And I just want to see what happens when I push play. A couple things I want you to notice. Notice the time. How many days does it take for our earth to revolve completely around the sun? Let's watch. Okay, you can see the force of gravity keeping the Earth in its orbit as it revolves around Earth. You're also noticing that the moon is revolving around the Earth. It's creating its own path. Okay, Earth and the moon have a gravitational field just like the Earth has with our sun. I'm going to pause it right there. It's pretty darn close, okay, right where we started. You guys can remember from the videos that it takes the Earth 365 days to revolve all the way around the sun, okay? I obviously have gone 2 days past its original starting point, so we're going on to year 2, okay? Now you're going to kind of play around what happens if we change the mass of our sun. If it decreases by half its size, how might it affect its revolution around the Earth? We can go play and see what's happening. Ooh, it looks like the gravitational field. We're losing gravity. It's getting weaker. Where did the Earth and the moon go? If I click right here, I can return them and I can start back over. Each time that you play with this, change one of these variables. See what happens to gravity. See what happens to the revolution in the orbit of these objects as they revolve around the sun. Okay, you're going to take time right now. You're going to pause the video, take 5 minutes, and just play around with this simulation. Welcome back. I hope that you had some good time to kind of explore the Earth and the moon and how it relates with the sun and how gravity kind of affects the emotion. Right now, you're going to answer a question: what controls? What variables did you find? Okay, what did you click? What did you notice? What did you change? What did you notice? Tell me what you changed, okay, and how it impacted or how it influenced the motion or the gravity of those objects. So go ahead and answer the question for the class discussion. Thank you. Welcome back. Now what we're going to do, we're going to keep moving on to number 2 as we go through this worksheet. You're going to compare the motion of the Earth moving around the sun. You've already played around with those variables. You kind of already know the motion of the Earth, but now I want you to compare it. What did you draw at the beginning as the Earth was moving around the sun? Can you redraw that right here? Tell me what was happening after you explored with that simulation. And will you please use the text box feature, and will you type a description? What is happening as the Earth is moving around the sun? After you filled out this section, now start looking at the moon. How does the moon move around the Earth? Can you please draw me a picture? And then can you please use the text box feature to show me, or excuse me, to explain the description? Just a reminder, when we're looking at the moon and the Earth, we need to change on our simulation to this section right here where we're just looking at the Earth and we're just looking at the moon. Remember, your gravity is turned on. You can see the gravitational force. You can watch its path, and it's easier to kind of view it on that grid. Okay, so I want you to describe to me, how is the motion of the moon around the sun? Draw me your picture and then tell me the description. Go ahead and push pause now. All right, so now we're going to do some more typing. What are some things you found that are the same about these motions? Okay, and what are some things that are different about the motions of the Earth around the sun, and as well as the moon around the Earth? What is similar and what is different about their motions? You're going to use this text box feature. Go ahead and type in right there. If you're following along with me, go ahead and push pause, fill in those 2 sections, and I'll see you back down here at part 2. All right, welcome back. We're now moving on to part 2, and we're going to do some more comparisons where we can look at what is going on if we change the variables of our simulation. What happens if we turn on the gravity versus what happens when we turn off the gravity? Okay, so for this section, draw the path of the Earth with gravity on. Again, you're going to use your drawing feature, and you are going to use arrows to draw the revolution of the Earth around the sun. But then go over and play with this simulation. Let's go ahead and turn off gravity. And you are going to draw, with the gravity toggled off, what is the path of the Earth in relation to the sun if we had no gravity. Again, use the drawing feature, draw arrows, and you're going to draw directly in these 2 boxes. Go ahead and push pause now. And then for part B, sorry that this formatting is kind of funky, but let me read it to you. Why do you think gravity is important? Okay, why is gravity important? You're going to use the text box feature, you're going to write in complete sentences, and you're going to answer from your perspective. Why is gravity important? Go ahead and push pause and fill that in. And I'll wait for you down here at number 4. Okay, welcome back. So number 4, we're going to look more at that simulation. We're going to change those variables. Over at question 3, we turned on and off gravity to see how that influenced the path of Earth in relation to the sun. Now we want to look at the simulation to find out how we can change the force of gravity and observe what happens. Okay, so first thing we're going to do, draw the sun's gravitational pull on Earth. Okay, remember, when we have this gravity force, we're on sun and Earth. Let's go back to this section at the top. Our gravity force is on. And if you notice that that isn't happening, one thing I've done to clear everything to go back to normal, click this button, clear, turn on gravity, turn on my path, turn on my grid. My sun is correct mass, my Earth is correct mass. Now I'm back at the beginning. Okay, so let's go back and remind ourselves. Draw the sun's gravitational pull on Earth. Okay, so looking here, sun's gravitational pull versus the sun's gravitational pull on the Earth. Okay, all we're doing in these two sections is we are drawing arrows. Draw the sun's gravitational pull on Earth, and then draw the Earth's gravitational pull on the sun. Okay, go ahead and push pause and complete number 5. Okay, now let's discuss. Why do you think the Earth moves, but the sun does not? Let me say that again. Why do you think the Earth moves, but the sun does not move? Go ahead and pause in this video, think about it. Using your text box feature, go ahead and type that in. Why do you think the Earth moves, but the sun does not? Push pause. Welcome back, number 6. Now we're going to go back and look at our pictures that we drew at the very beginning. And I told you just to draw arrows of that invisible force. As we've gone through, you've realized that this invisible force is the force of gravity. So I want you to go back to question 2 using your text box feature, and I want you to give it a caption. What do those arrows mean? Okay, I'm telling you right now that the arrows mean this force is that very special force that keeps us all alive and on tact and moving appropriately in our solar system. That force is called gravity. Go back and label that on question 2. Push pause and I'll see you down here at question 7. Okay, welcome back. This is where you're going to explore some more. You're going to play with the simulation to find ways to change the length of the blue gravity forces. How can we make the force of gravity stronger? What can we do with those objects versus what can we do to make the force of gravity weaker? Increasing gravity is stronger, decreasing gravity is weaker. So let's go through and kind of play, and we're going to fill in the action. The action is what are we changing on our simulation? What are the variables? And then you're going to tell me whether the gravity increased or did the gravity decrease with the action that we chose. Okay, I'm going to show you an example of the first one they gave you. Put the star, which is our sun, and our planet, which is Earth. Let's put them closer together and let's see what happens to the gravity. Go back to this link. Okay, remember we're looking at sun and Earth system. They're telling us what happens if we put them closer. Did you see how those arrows came together? That tells us that the force of gravity increased because those objects became closer together. Let's watch how it affects its path. Uh-oh. Look how much closer Earth gets to sun with an increased gravitational force. And look here, I paused it right after one full revolution. What happened to the time? Did it take longer or shorter amount of time for the Earth to revolve around the sun when the Earth is closer? Normally, it takes 365 days for the Earth to revolve around the sun. But when we move the Earth closer to the sun, the gravitational pull gets stronger and the amount of time decreases. It goes faster around the sun when those objects are closer together. Okay, I'm going to go back to the beginning and I want to play with more of these variables to see how can I make these arrows come closer, or what happens if I move my object away? What happens to the gravitational pull? So going back here, you need 1, 2, 3, 4 different actions that are going to change the length, okay? Change the length of those blue gravity force arrows, okay? Tell me what you do, and then you're just going to tell me if gravity increases or if gravity is decreasing by the change that you made on the simulation. So go ahead and push pause, and you're just going to play around. You're going to explore with that simulation to see how can we make those arrows either closer together, gravity force is increasing, or what are you doing to change the gravity force so that it is decreasing and those arrows get farther away? What are you changing? What variables are you manipulating to change the force of gravity? Go ahead and push pause, and I'll wait for you down here at letter B. Okay, so when we get to letter B, we're using our text box feature again. And what can affect the strength of the gravitational force? And what can you conclude? We already know, I'm going to give you this one. We already know distance affects the gravitational pull between our sun and Earth. When objects are closer together, the gravitational pull increases. So if we put them closer together, that pull, that force is bigger, it's stronger, it increases. What would be the opposite? What would happen if those objects were farther apart? And when objects are farther apart, the gravitational force, it decreases. Okay, so that was one thing that we discovered from our first example. If you have anything more that you want to add to that based on your discoveries, let's fix my errors. Please go ahead and add that in this section using the text box feature. Okay, let's move on. Let's move on to number 8. We're going to do some more comparisons. Compare these two cases. Again, we're looking at the sun, and here is our Earth. Here's the sun, and here's our Earth. What is the difference between case 1 and case 2? Go ahead and use your text box feature, and what changed between these two cases? Go ahead and push pause, fill that in. Thank you. Now let's go back and let's look at our simulation for these two cases. I'm pretty sure that you noticed that our sun, it decreased in size. It got 50% smaller. Let's go see what it looks like on our simulation. Okay, you know that you can decrease the mass, and we're looking at our sun, by 50%. Okay, now it's asking us to draw the force of gravity on Earth in each of these cases. What'd you notice with that force of gravity? Let me put it back to normal. Okay, notice where the arrows are. Watch what happens when I decrease in size. What happens to the gravitational force? What happens to the length of those arrows? Go ahead and push pause, use your text box feature, and will you please answer, okay, what has happened to those arrows? Okay, you can draw those arrows up here in these boxes. Okay, once you've drawn your arrows for letter A, I'll meet you down here for letter B. We have 2 more cases we're going to compare. Welcome back. Now we're looking at 2 different cases. Okay, What is different about case 1 than case 2? I'm going to show you, and I want you to notice a couple of things. We have a faint line right here in the middle. How many faint lines do you see in between the sun and the earth on case 1 versus how many faint lines do you see on case 2? Please use your text box feature and tell me what has changed or what is different about each of these cases. Thank you. After you have explained what changed between case 1 and case 2 right here, now I want you to draw those arrow forces, the forces of gravity again, on your simulation. Okay, we know Earth is closer together, gravitational field, excuse me, increases. What happens, let's minimize, when we have 3 lines in between the sun and the earth? 1, 2, 3. Whoa! What happened to the gravitational force between those 2 objects? I want you to draw the force of gravity in each of these cases. Go ahead and push pause now. Okay. Welcome back. Part 3. This is where we're going to fill in a table to help figure out more discoveries of what happens with gravity and the celestial objects in space. This can be a little challenging, so I'm going to let you explore. You have 3 different scenarios that you need to look through. How can you make the moon go around the earth in a larger circle, in a larger revolution? You're going to need to go back to your simulation, go to your earth and your moon, and how can you make this circle larger than this right now? This is the actual revolution of the moon around the earth. Change some of these variables to figure out how you make that path around the earth larger. Explain what changed, what variables did you manipulate. Draw the motion of the path using this drawing feature. Go ahead and draw to me what's happening. And then what other changes do you notice? Okay, that's number 1. Then I want you to, how can you make the earth take more time to go around the earth? Let's go back to our simulation, sun and earth. We know, ooh, look how far away this is. I haven't reset it. Reset, grid, path, gravity. Okay. Currently, we know that it takes 365 days for the earth to revolve around the sun. And we want to know, how can we make the earth take more time? What are you going to do with these 2 objects, the sun and the earth, so that it takes more than your 365 days? Okay, change some variables, manipulate some of these settings and controls that we have on the simulation. Come back here, explain what you did using the drawing feature, draw what happened, and then what other changes do you notice? The last and final one, how can you make the earth take less time to go around the sun? What are you going to change? What are you going to manipulate on our simulation to make the earth take less time to go around the sun? Go ahead and push pause, and I want you to work on this section, part 3, and these 3 different scenarios. Welcome back. This post lab could be done tomorrow on Tuesday. If you've been working super hard today, it is not due until Friday. But this is kind of a reflection of everything that you just did in the lab before. Okay, let's just go through this. In the picture below, draw how you think the earth and the sun move. Now we've added the moon. You've seen the simulation when we add all 3 of these objects. Push play. I want you to draw what is happening. And remember, on this picture, you're going to show those gravity forces. So make sure that you are drawing these blue arrows on your picture as well. Go ahead and push pause. Do problems 1 and 2. Thank you. Welcome back. Number 3. This is where we're going to start predicting. What do you think is going to happen in each of these cases? So let's just go through them. Predict what would happen to the gravity force Remember, what would happen to these blue arrows if we increase the size of our sun? What would happen to those blue gravity force arrows if we moved the star, our sun, and the planet away from each other? We kind of already investigated that. Would gravity increase? Would gravity decrease? Or would gravity stay the same? And don't forget to add a drawing. What do you think would happen if we decrease the size of our planet? Is gravity going to increase, decrease, or stay the same? And make sure you add me a drawing. And last, but certainly not least, what would happen if we move the star, which is our sun, and the planets closer together? We've kind of already investigated that. Tell me what's going to happen with gravity and draw me a little picture. Okay, looking at number 4. Show in the pictures below how you think the Earth and the Moon would move if there were no gravity at all. Remember, we can go back to our simulation and we can turn off our gravity. And remember, we're working in the sun, the Earth, and the Moon system with gravity off, and you are going to draw what you think is going to happen with the Moon, the Earth, and the sun with no gravity. Go ahead and push pause and draw. After you've drawn what you think is going to happen, now you are going to type and you are going to explain why you think the Earth and the Moon would move in that weird, crazy path. Use your text box feature and explain why. And then last but certainly not least, this is just a little reflection, number 5. Tell me what you think about this activity. Okay? Was it useful? Okay, compared with other assignments that we've done? Okay, using this digital simulation, is that more useful to understand the concept? Is it about the same, the things that we've already done, or is it less useful? How enjoyable was it working with the simulation and showing me your thinking on this document? Was it more enjoyable? Is it about the same than things that we normally do, or is it less enjoyable? And then last but not least, just go ahead and text box feature and tell me why. Once you have completed this gravity and orbits activity, where we were using the simulation as evidence to kind of guide us through this activity, go ahead and push turn in, and you are done for today. Thank you so much for everything. I miss you guys a lot.